Well, I'm back on the fan scenario. Um, I want to take a break from the handheld. I got an idea how to build it, but that's going to be a big process. I'm going to do it after lunch. Right now, I want to get this fan going. I want to get that speaker in. I want to get these heat sinks put on and get this thing on more back on some tests and get some real numbers to make sure we know we got it. Okay. What I wanted to show you first was the power supply conditioning requirements for some things, in particular for this fan, but for other things potentially down the road. But we're starting out with our track power, and we have 5 to 12 volts AC out of this old bomb here, and other transformers will give me 15, and my big Mike's Train House unit will give me 22. So bear that in mind. But this one is a 5 to 12 volts that goes through these rectifiers, and the rectifiers are an AC to DC conversion process. And when they do that, sometimes they increase the volts. So what I get now is 5 to 14 volts DC coming out. Okay, so I got 14 volts. This is a 5-volt fan, so that's too much, right? So then what I put in was what's called a 7805, and that's a little transistor. It has 3 leads. One lead is the power in and the ground. The other lead is the power out and the ground. And what it will do, the 5 is the designator there, it will take the power coming in and reduce it to a constant 5 volts. That's all you do. Just wire it in, you got 5 volts. As long as it's DC to DC, right? It has some capacity limits, I forget what, but at any rate. So I did that, and I plugged it in, I turned on the power supply to the transformer. The engine's running, everything's working, got forward and reverse, no fan. Fan didn't work. Brand new fan, right out of the box. What I found was none of the fans that I bought worked, frankly. And I went through them. I tried to figure it out. This is a blower fan, very small one. I would have used it, probably. It would have fit. Much smaller than this one. This one's a better fan. I thought, all right, let's back up a second. All these fans don't work. So I plugged it into my bench power supply, what's called a triplet. It's a PS305. That's a power supply, goes up to 30 amps and 5 volts. Or 30 volts and 5 amps, excuse me, flipped it over. I put it on 5 volts, fan runs. 5 volts, fan runs. 5 volts, fan does not run. What's going on here? I have here an amp, unlimited amp supply because I got 110 on the back end, right? This one I have limited amp supply because of the way it's being converted in the low volt range of the transformer. But there is a way to get around a low amp start requirement, and I don't really know much about it other than I've read that capacitors are used sometimes as a starter capacitor for a fan motor, most importantly in your furnace. Your furnace has a huge fan motor, and it may not start on 110, whatever you're giving it, 10 amps, whatever. But if you put a capacitor in front of it, a capacitor is like a battery or a reservoir. It stores up energy to a point, and it can send it out if there's any dips. It smooths out rippling current, but it also can smooth out something that's just too low to crank the motor over. The motor's asking for more. He says, oh, I got some more now, look at this. And he hands it off. And the fan motor starts instantly every time. So I grabbed some of my box, and I do have a box of capacitors, and I read through the volt requirements, and they're rated in what's called microfarads or puffs. It's a lowercase u and a p, and I started out with a 22 micro puff rated at 25 volt capacity, and I only had to turn the transformer up to 30 miles an hour, 30, and the fan started. What? And I turned it off, and the fan kept running for a few moments because there was energy stored in this capacitor, and then it stopped. But when I start it slowly, like at 10 and 20, the fan will just stutter. It won't really start. But I have to get it up to 30 and it'll take off. Well, that's probably okay. Train's going to be pulling. It'll have a load. It'll require 30% just to move. But I thought I would go through my pile and see if I can run it on anything lower. So I went down to a 47 at 25 volts, and it still needed 30%. It did run though. I went down to 100. I went back up to 100 at 25 volts, and it ran, but at 30%. So I'm wondering, well, I've got 100 over here. I got 100 at 10 volts. Maybe that will work better. I don't know. So I put the 100 micro puff at 10 volts rating, and I get a start at 20%. The fan starts at 20%, which is much better for us because that's at a lower speed. And if this works like it just did, I get my hands in here. You can see it stuttering right now. I'm below 20. I'm right at 20. I may not be enough up above it. There it goes. I'm at like 25, and it took off. You can see the blade is a blur, so it's running. And there's air coming out the backside. That's the vent comes out the back. It's a blower, so it's grabbing air and shoving it down, which is what we want to do here. We want to take this air and push it down that cavity down there. And that's what this is going to do. And that big opening is better for us than that little opening. So I think I'm going to be okay. I might be able to use those on other things, maybe for point solutions. You know, I was thinking when I put smoke in cars, you know, like the firebox in, not the firebox, the stationary smoke, like in a caboose, right? You might need a fan in there to keep that system cooler, and because we have similar components if we do that, and that may be a way to do it. At any rate, I think this is great. And no matter what I crank it up to, it's held at 5 volts, and we're good. So I need to add my 7805 to turn 12 volts into 5. Then I need to add this start capacitor. Performs the function of a starting capacitor for the motor. I need to add this into that circuit as well, and then plug this motor into it. So it looks like I might have to do a tiny little, either a glob, you know, like just put the stuff together and run it, or put it on a tiny PC board somewhere. Oh, I saw smoke and I got nervous. I thought, oh shit, something's smoking. Well, yeah, you're running the engine. Look at how slow it's running. That's at 25 miles. You can see it. The background's not too great for you, is it? There it goes. Is that something? I didn't even know it was running. I saw the smoke, scared the crap out of me. That doesn't take much anymore these days. They're running. Now you know it's running. Firebox. See the firebox in there? Oh boy. Okay, so the fan is running. I'm going to put in these. Oh, I want to show you these heat sinks. This is the heat sink that's on there now. It's one that I made out of a bigger piece of aluminum. I just cut it down to fit the size of that chip. In the meantime, I had found and ordered an official heat sink that actually bolts on with a screw and everything. But as you can see, it gets a little crowded in some of those places. So I'm going to have to fit them, and I may have to grind some of this lower piece off down here. It might dig into some of the components or get in the way of that screw or something like that. So we'll see what we can do, but I'm going to keep the big fans on the front for sure, because they're all going to be pointing forward. And if you look, it's hot too, damn it. Okay, don't touch me. Need the heat sink on, and we need the fan on. I'm gonna turn this down. I'll turn this off. Okay, that's the show. Got the fan running. I got a really good heat sink I'm going to fit in, and then I'm going to bring the speaker over and put it inside this box, which is built for the assembly. And then I'm going to assemble these. These are the reinforced sides. This is the inside of the piece, so you can see it's going to be stiffer. This is the outside. This is my attempt at rivets. I might give up on rivets and hand that all off to Leon. I did put some supports onto the back side of this. Oh, and I got one more thing to show you. I've had this material. Here it is. I know this may sound silly, but Margaret's hair hair dryer broke, and or it just stopped working. So I took it apart to see if I could fix it, and I could not. It was something inside a switch of some kind. But in any case, inside there is a heater, and around this heater was this material, which is sort of a resistant heat reflecting material. And I thought, hey, that's heat reflecting. I might be able to use that. So I'm thinking I might cut some stripes of this and put it on the panels that fit near the hot end of it. So I have some reflective heat going in. I got the fan pulling it out, and I got the big fins, whatever they're called. I just forgot it already. Anyway, that thing. Put that on, all four of them, tuned up to fit. Get the speaker going, and then retest everything. And I think this. But you see how smooth that was running at 525, whatever it was. Wow, that's pretty cool. Okay, and Leon has confirmed he doesn't need the body. He just wants the chassis and the tender, and he'll take it and he'll do an inspection. He'll run it through his system. He'll build his engine, and he will tell me and you through me. He'll send a report, and I'll pass it on, how it went and what he's getting out of it, and does he like it, and what's next. Okay, and then the coal, still came out pretty good. And oh, in the course of searching for something, I found a coal load. Oh, I'll show you this engine because it's really cool. Or can I? Not here. It's over here. Is it over here? Oh, no, it's in a box. I'm so sorry. I have it, but it's not out. It's American Models steam engine, but it was a Streamline K4, and I converted it to run on atomic fuel. So we didn't need the coal load anymore. But look at this. That's the coal load. That's a coal load from American Models, and that's a coal load that I made from scratch over on my bench. I know it's a little crude, but hey, you know what? It's not bad. It's not bad. So that was the idea. I just wanted to share with you how that went. Okay, so I'm gonna get back to work. This has been going on probably a little too long, but I thought you should see, if you ever have a DC fan and it's not starting on your power, try a capacitor. Give it a little starting capacitance, and it may help it as it did this one. So that's it. Back to work. Later, gang. I'm hoping I can get to work on the mini mill. And then, of course, I want to get started on my handheld. I had something to show you now. I don't even see it. Oh. Where did I put it? Wow, that's strange. I had assembled the screen into the case. Well, it was here a minute ago. Oh boy, losing my mind again. It happens. Well, it's got to be here. Nobody would take it. Nobody wants it. I'll find it, show it to you later. Anyway, I got the screen, the little LCD, LED screen mounted in the case, and I'm going to be using PC boards to hold things together and put them inside the case. So I think we got a plan to build this. I might have to get a bigger case eventually, but right now I think I can build this and get it going. So that's part 3. First, we're going to get this thing buttoned up with a fan. Second, I'm going to work on my mini mill, get all the parts I need, and put it in the ball bearings, okay? And then I'm going to get back onto the handheld. And it's only 12:30, so I got some time. And Super Bowl's over. Everything's calm now, so we're all back together. That's it. Later. Take care. Keep watching. Appreciate you. Bye for now.